Okay, now continuing on with this, with compound interest. Here's example 5. Here we got a $9,000 amount invested at an APR of 1.3% for 17 years. The balance in the account after 17 years is how much? Here we want to find out what that is. Okay, so now, our principal is $9,000. The APR, that's going to be 1.3%. But if we change 1.3% to a decimal, it will be 0.013. Y is the number of years, that is 17%. Okay, and it is compounded annually, by the way, so we have to use that formula still. A is equal to P times the quantity 1 plus APR raised to the Y power. Your principal, P, is $9,000. That's multiplied by 1 plus our APR of 0.013 raised to the power of Y, which is 17. And on the calculator, we type in 9,000 times, and then left parentheses, 1 plus 0.013, close parentheses, the hat key for your exponent, and then 17. And then hit enter. Now to the nearest cent, we're going to say that this will be $11,209.93. And when I say to the nearest cent, we always round to 2 decimal places. So the balance in the account after 17 years is $11,209.93. Okay. Now let's look at compound interest that is paid more than once a year. Okay. In this case here, we're going to use a different formula. In that case, A is equal to P times the quantity 1 plus APR divided by N raised to the N times Y power. Now in this case here, your accumulated balance would be your A after Y years. Your capital P is the starting principal. APR is the annual percentage rate as a decimal. And then N is the number of compoundings per year. And Y is the number of years. Now, let me explain the number of compoundings in a year. If it is compounded daily, that means there are 365 days in a year. N is 365. If it's monthly, that means N is going to be equal to 12. Quarterly compoundings means that N is equal to 4. Semi-annually means that N is equal to 2. Quarterly, there are 3 months in a quarter, so it's done 4 times in a year. Semi-annually, only twice, the first 6 months and the last 6 months. And monthly, there are 12 months in a year. N is equal to 12. Now let's look at example 6 that uses compounding paid more than once a year. Like example 6. Here we got $23,000 invested for 4 years with an APR of 4% and is compounded daily. Okay? So we want to find out what the balance in the account is after 4 years. So your P here, 23,000. Your Y, that's going to be 4. Your annual percentage rate is given as 4%. But of course, 4% as a decimal, we take 4, divide that by 100, you're going to get 0.04. And it's compounded daily. That means we're going to let n be 365. Okay, so this is our formula. A is equal to P times the quantity 1 plus APR divided by N raised to the N times Y. So here your principal, $23,000, times 1 plus your APR, that's 0.04, divided by N, that's 365, raised to the N times Y. N again is 365 times Y, which is 4. Now all of this can be typed in the calculator. Here we got 23,000, we're going to type that in, then left parentheses, 1 plus 0.04 divided by 365, close parentheses. For the exponent, we press this hat button, and then left parentheses, 365 times 4, close parentheses, and then hit enter. Now here we're going to round to 2 decimal places, so that amount would be $26,990.51. That represents a balance in the account after 4 years. Okay, example 7. We got $6,000 invested for 18 years with an APR of 3.41%, and this time it's compounded monthly, and we want the balance in the account after 18 years. Okay, so now our principal, which is your P, that's $6,000. The Y is 18 years, that's given to you. Your APR is 3.41%. Well, we take 3.41% and convert it to a decimal by dividing by 100, you'll get 0.0341. And now we still use that compound interest that's paid more than once a year, that formula. A is equal to P times the quantity 1 plus APR divided by N, and that's raised to the N times Y. Here your P is $6,000, that's your principal, times 1 plus your APR, that's your 0.0341, divided by N. Now it's compounded monthly, I forgot to mention that. So that means N has to be equal to 12. So your 12 will be in your denominator under the APR. Your N in the exponent is still 12 times the Y, which is going to be 18. So to find out what that amount is going to be, here we're going to do 6,000, and then left parentheses 1 plus 0.0341 divided by 12, close parentheses, and then press the hat key for your exponent, then left parentheses 12 times 18, close parentheses. This will be $11,074, and to 2 decimal places, 0.99. So $11,074.99 represents the amount or the balance in the account after 18 years with a monthly compounding. Okay. Okay. Now let's look at annual percentage yield, or APY. In this case here, the annual percentage yield is also called the effective yield, or simply yield. That's going to be the amount, the actual percentage by which your balance increases in 1 year. It is equal to the APR if your interest is compounded annually. It is greater than the APR if your interest is compounded more than once a year. So these are the abbreviations here: APR, annual percentage rate; APY, annual percentage yield. And if it's compounded annually, if your interest is compounded annually, your APY will be equal to the APR. But if the interest is compounded more than once a year, then your APY will be greater than your APR. Like in this example here. Find the annual percentage yield in the following situation. A bank offers an APR of 5.5% compounded daily. Okay, so now, this is what I'm going to do here. I want to let P equal to $1,000. And the Y is going to be 1. Okay? Because we're going to deal with just that first year. So Y is equal to 1. You're given the APR of 5.5%. Convert 5.5% to a decimal, you're going to get 0.055. And then it says compounded daily, so that means that there are 365 compoundings in a single year. N is 365. So now we got to use that formula of A is equal to P times the quantity 1 plus APR divided by N raised to the N times Y power. We're going to find out what the amount is at 1 year compounded daily for a $1,000 investment. Your P is 1,000 times 1 plus your APR of 0.055 divided by N, that's 365, and that's raised to the N times Y. 365 times 1. N is 365, Y is equal to 1. So if I type all of that in the calculator, let me clear this out. We'll do 1,000, left parentheses, 1 plus 0.055 divided by 365, and then close the parentheses. Use your hat key for the exponent. 365 times 1. Now that can be done with or without the parentheses. And then hit enter. To 2 decimal places, this will be, let's say, $1,056 and 54 cents. That will be the amount after 1 year of a $1,000 investment at 5.5% compounded daily. Now, I need to find out what they call the absolute increase. That's going to be equal to the amount that I came up with after 1 year minus the principal. This amount was $1,056.54. Subtract from it the principal of $1,000. You'll get $56.54. That will be the absolute increase. And now for the annual percentage yield, that's going to be APY. We take the absolute increase, divide that by your principal, multiplied by 100%. because APY is a percent, just like APR is a percent. Your absolute increase is $56.54. Divide that by the principal, we'll let P be $1,000, and then multiply that by 100%. Now, if we type all of this in, let's say the two decimal places, this will be 5.65%. So that will be your annual percentage yield for this. Okay. Now let's talk about continuous compounding. Now, continuous compounding is this formula: A is equal to P times E to the APR times Y. Now, your A, of course, is the accumulated balance after Y years. Your P is going to be the starting principal. Your APR is going to be the annual percentage rate as a decimal. Y is the number of years. And E is the special irrational number with a value of approximately 2.71828. Okay, irrational means that it is a non-terminating, non-repeating decimal, by the way. And on your calculator, you do have the E. To get that, you'll have to press this key, second and the LN key. Second and LN will give you the E. So on the calculator, second, and then LN gets you the E. Okay. So now let's look at some examples of continuous compounding here, like in example 9. Here you're going to use the formula for continuous compounding to compute the balance in the account after 1, 5, and 20 years. Also find the APY for the account. That's the annual percentage yield for that particular account. A $14,000 deposit is in an account with an APR of 2.5%. And we want the amount after 1 year. So here, after 1 year, that means your Y is going to be equal to 1. And in this case here, your P, the principal, is the $14,000. Your APR, annual percentage rate, is 2.5%. 2.5% as a decimal will be 0.025. Okay. So now we use that formula. A is equal to P times E to the APR times Y. Now your P is 14,000, that's your principal, times E to the APR of 0.025 times the Y, which is going to be 1. So here we go. 14,000 times, for the E, second, and LN. Second, LN gives you the E. I repeat, second and LN gives you the E. And then for the exponent, left parentheses, 0.025 times 1. Close parentheses. Hit enter. Now the two decimal places to the nearest cent, or to two decimal places as they say, $14,354.41. So after 1 year, the account will have $14,354.41. Okay, now let's look at after 5 years. that means y is going to be equal to 5 this time. We're still going to use that same formula here. So here a is still going to be equal to still 14,000 for the p, multiplied by e to the 0.025 still, but this time multiplied by y. Y is going to be 5 here. Now, if you don't want to type all of this over again, you can do the second enter, because I did this before with 1 year. Now I'm going to use my left arrow key to go up here in this exponential part and change that 1 to a 5. So now we got 14,000 times e to the 0.025 times 5, equaling to, let's say the two decimal places, $15,864.08. Okay, so that's after 5 years. And now after 20 years, that means y is equal to 20. Same formula, the same numbers for P and for your APR, but here the y is going to be 20. And here I'm going to do second enter, use my left arrow key, type in, instead of 5, 20, 20, and then close the parentheses. Now here, our amount would be $23,082.10. $23,082.10. That would be the amount after 20 years. Now, here we need to find the annual percentage yield, the APY. We first find the absolute increase. Now we have to use the amount after 1 year to get the absolute increase. Not for 5 and not for 20, just a 1 year. We came up with $14,354.41. Let's subtract that from the $14,000 that we got. That will be the deposit. This will end up being $354.41. That will be your absolute increase. And now for the APY, annual percentage yield, we had to do the absolute increase divided by the principal multiplied by 100%. So in this case, the absolute increase was at $354.41 divided by the principal of 14,000 times 100%. So 354.41 divided by 14,000 times 100, times 100. It'd be 2.53 if we were to round the two decimal places here. So 2.53% represents the annual percentage yield for this particular account. Okay. All right, next we'll look at another example, example 10. Here we're going to use the formula for continuous compounding to compute the balance in the account after 1, 5, and 20 years. And then we're going to find the APY for the account. A $5,000 deposit is in an account with a APR of 3.7 So we have our principal of $5,000. The APR is 3.7%, but as a decimal, we're going to use 0.037. Now, it does say use the formula for continuous compounding. So now, after 1 year, your y is going to be equal to 1, and we're dealing with continuous compounding. We have to use this formula, a is equal to p times e to the APR times y. So in this case, our a is equal to p times, well, p is 5,000, times e to the APR, that's 0.037, times the y, which is 1. So here, 5,000, times, for your e, second ln for your e, as always, and then left parentheses 0.037 times 1, close parentheses. Under two decimal places, this will be $5,188.47. That will be after 1 year. Now, after 5 years, that means y is equal to 5. It's still continuous compounding, so we still are going to be using this formula here, but we just changed the y to a 5. So your p is still 5,000 times e to the 0.037 still. Now it's going to be multiplied by 5. And in this case here, I'll go ahead and retype this. 5,000 and then second ln for the e, 0.037 times 5. Now, if we were to round that off to two decimal places, it'll be $6,016.09. And then after 20 years, here y is equal to 20. The formula is still the same, and the values for p and your APR is still going to be the same. Only thing will change is the y. So now you're going to have 5,000 times e to the 0.037 times 20. So 5,000, and then second ln for your e, 0.037 times 20. This will be $10,479.68, rounded to two decimal places. That will be the balance in the account after 20 years. Okay. Now, the APY is what we need to find. Your absolute increase we have to look at the amount after the first year, which is in this case $88.47. And we're going to subtract from it the $5,000 deposit. And that will give us $188.47. That will be your absolute increase. To find the APY, or the annual percentage yield, we take the absolute increase divide that by the principal, multiply that by 100%. So your absolute increase was at $188.47. Divide that by the principal of $5,000, and then times 100%. And you'll end up with this. To two decimal places, this will be 3.77%. That will be the annual percentage yield for this particular account. Okay, the last thing in this particular section 4B is planning ahead with compound interest. So here you want to find out how much you need to deposit today in order to have a certain amount at a certain period of time. And that could be to buy a car, buy a house in this case, whatever. How much must be deposited today in the following account in order to have $50,000 in 8 years for a down payment on a house? And you want to assume no additional deposits are going to be made. So here, an account has an annual compounding and APR of 4%. Okay, so now, in this case, we have to use this formula. A is equal to P times 1 plus APR raised to the Y, because it says annual compounding. We have to use that formula. Now I'm going to manipulate this formula a bit, because I'm going to get P by itself. It's being multiplied by that 1 plus APR to the Y. So I'm going to divide both sides by 1 plus APR to the Y. So this is what P is going to be equal to. And I'm going to write the P in front, and then that A over 1 plus APR to the Y. I'm just putting the P in front. They're both the same, but I'm just putting the P in front to make it more simpler. Okay? So here I'm going to be finding out what the principal is in this case, the amount that I need to deposit today. I'm given, okay, I want to have $50,000, so here that would be A, not P. In 8 years, Y is equal to 8. We got an annual compounding, so that means your APR, we got that to be 4%. Again, 4% as a decimal. If you do 4 divided by 100, you're going to get 0.04. So here I'm going to use this formula and substitute those values into that formula to find out what P is. So here P is equal to A, which is $50,000, divided by 1 plus APR, the annual percentage rate is 4. That's going to be raised to the power of 8. So here's what I'm going to do. 50,000 divided by, and then left parentheses, 1 plus 0.04, close parentheses. That's going to be raised to the 8th power, and then hit enter. Now we're going to do this in dollars and cents, so that means to 2 decimal places, I would need $36,534.51. I have to deposit that much today in order to get $50,000 in 8 years at an annual compounding of 4%. Okay. And finally, example 12. How much must be deposited today in order to have, in the following account, in order to have $105,000 for a college fund in 17 years? And we're going to assume no additional deposits will be made. And the annual compounding again with an APR of 5.1%. Now, if you recall, I'm going to go ahead and rewrite that formula that I used. That P is equal to A divided by the quantity 1 plus APR raised to the Y. Now, in this case here, we want to have $105,000. And Y is going to be 17 because we want that in 17 years. The APR, the annual percentage rate, is 5.1%, but as a decimal, it's going to be 0.051. Take 5.1, divide that by 100, you'll get the decimal value of your APR. So here P is equal to, here A is $105,000, divided by 1 plus, here your APR, that's going to be 0.051, raised to the Y, which is 17. And then, if we simplify that, $105,000 divided by, and then left parentheses, 1 plus 0.051, close parentheses, raised to the 17th power. Now to two decimal places, $45,075.77. That is the amount that I need to have deposited today in order to get a college fund of $105,000 in 17 years. Okay, so that will complete this particular video on the power of compounding.